Is this function less than x? And what does that even mean? This was a question that students at UCLA got, and they're being asked whether or not the function grows a lot smaller than the other function. Now, you can go ahead and graph this and you can easily get your answer, but it's best to go ahead and solve this using a limit. So we're asked to verify whether natural log of x to the power of 2 is less than x. And as I mentioned, this basically means, is this function growing slower than that function? And the way we're gonna do this, no, we're not gonna graph, we're gonna go ahead and use a limit. We're gonna set this up as the limit as x approaches infinity, and then we're gonna take this function, natural log of x to the power of 2 all over x. And think about what's gonna happen here. If this in fact grows a lot slower, meaning this will grow faster, this number will get much bigger than the top. In other words, this limit will approach 0. And if we can prove that this limit is equal to 0, then we have proven that this is less than x. In other words, this function is growing far smaller than this function x. Well, how do we go about it? We can go ahead and plug in infinity. By that, I mean plug in. What would happen if this approaches infinity? Well, this will be infinity, that will be infinity. So we have infinity over infinity. Right now, we don't know if this is equal to 0. This is infinity over infinity. So we can apply the trusted L'Hopital's rule. So let's go ahead and do that. Now remember, when we apply L'Hopital's rule, you are taking the derivative of the top and the bottom separately. You are not doing quotient rule. So in this particular case, we will have 2 natural log of x to the power of 1 times the derivative of 1 over x, which is, or the derivative of a natural log of x, which is 1 over x, apologies, over, and then this derivative will just be 1. So this limit turns into 2 natural log of x all over x. Once again, we can go ahead and plug in infinity, and this will give us infinity over infinity. I didn't mention, but we should definitely have an understanding of how natural log looks. Keep in mind, it has a vertical asymptote at 0, and it just grows exponentially this way. So as we approach infinity, this function also approaches infinity. So we still have infinity over infinity. Well, let's go ahead and take L'Hopital's rule again, because calculus allows us to do that. Thank you so much, Mr. L'Hopital. All right, so let's go ahead and take the derivative of this. This is gonna be 2 times 1 over x over 1. That's just it, because the derivative here is going to be 1. Now we can go ahead and plug in 1, and we have 2 times 1 over infinity. Now, 1 over infinity, think about it. You have 1 pizza being divided by infinitely many people. So how much of a slice is each person going to get? Virtually none. You get nothing. So we have 2 times 0. In other words, we get 0. So that tells us that this function on the bottom is growing much faster than the function on top, therefore making this proportion equal to 0 or approach 0, thus proving that this function grows a lot slower than the function x. And that's how we do that particular calculus problem.